Greetings, everyone. Welcome to July's meeting for the East Brunswick Astronomy Club. So excited to see some young faces here and some returning faces, of course. So every season, so today we're actually learning about Venus, the hottest planet. We're going to talk about what happened to Earth's twin. Some people think of Venus as Earth's twin. We'll hear a little bit more about that. And this is just what we're going to be covering tonight. I'll give you a little bit of an introduction to who we are and what the club is in general, as well as learning about Venus, learning about what happened on Venus and the greenhouse gases here on Earth. We'll actually be joined by the Sustainability Task Force of East Brunswick as well to learn more about greenhouse gases. We have a craft for the kids that are here with us tonight, and the big and little kids, and the very tall kids as well. And we'll conclude by looking at the sky and hearing from our club president talk about what we can see visibly in our night sky tonight. So the East Brunswick Astronomy Club was founded with the mission of encouraging and promoting interest in astronomy and space science throughout East Brunswick and beyond. We meet once a month, every third Thursday here at the East Brunswick Library. And once a season, we have a kid-focused meeting for younger stargazers, which is also usually hosted and co-lectured by a junior astronomer. About us specifically, this is
Kevin.
How old are you, babe?
5.5, aka almost 6.
And I'm his mom, Christy. And together we have enjoyed adding astronomy to our favorite hobbies. And here's actually a picture of our whole family presenting at March's meeting on the Mars rovers. If you're interested in learning more about the Mars rovers.
April.
April. Probably. He has a better memory than I do. If you're interested in learning more, our club also has their own YouTube channel where we post previous meetings. So if you'd like to learn more about the Mars rovers, you can check our presentation from that date.
Venus is the second planet closest to the sun. Since it's so close to us on Earth, it sometimes looks like the brightest star in our sky. Its nicknames are the morning star or the evening star.
So, little pop quiz. Does anybody know what Venus was named after? Was it A, Dr. Reginald Venus, like an old-timey astronomer man, a Venus flytrap, the Greek god of fire, or the Roman god of beauty?
Dr. Reginald Venus.
Okay, so we have one vote for Dr. Reginald Venus. We have a vote for the Roman god of beauty. Another one. No one was fooled by the alluring Venus flytrap? No? Okay. So the answer is the last one, the Roman god of beauty. The planet Venus is the only of the planets named after a female goddess. Okay, so Buddy, how do we know so much about Venus, even though it's so far away?
So far, there have been 49 attempted missions to Venus. This includes landers, orbiters, probes, and flybys. Flybys are the most common way we observe Venus. It's just when a craft doesn't land, it just flies by.
So we have many notable missions to Venus. Like Kevin said, there's been 49 attempted ones, because oftentimes we stop by Venus on our way to the other places, such as the Parker Sun probe, stopping by Venus or flying by to gather images on its way to really study the sun. Most notably, the Venera missions was the first to land on another planet.
Venera 9 and Venera 10.
Very nice.
Venera 9 and Venera 10.
So some people call Earth and Venus twins. Why is that?
That's because all the planets in our solar system, Earth and Venus, have the most similar size and mass. Each planet has an iron core center surrounded by a hot rock mantle and a rusty crust on the outside. Both planets also have volcanoes, but that's where the differences stop.
Okay, so we're about the same size.
Mama.
We have the same type of three-layer composition. But that's really where Earth and Venus stop being similar, because there's actually a lot of differences. So one Earth day is how many days on, well, what is a day on Venus in compared to Earth days?
243 Earth days.
So one of our days, or 243 of our days, that's a lot of time. It's almost as close as our year. Our year is 365 days. How many Earth days is it for Venus?
225 Earth days.
Whoa, so their year is shorter than the day? Is that true?
Longer. Shorter than the day. Yeah, shorter than the day.
That's pretty wild. You know, Earth has one moon.
Venus has no moon.
Here on Earth, you wouldn't believe it during the summer, but the average temperature here on Earth is 60 degrees Fahrenheit.
But the average temperature on Venus is 850 degrees.
Our atmosphere is made primarily out of nitrogen and oxygen.
But the atmosphere on Venus is mostly made out of carbon dioxide.
That's the stuff we breathe out, right?
Yeah.
Yeah. Yeah. So when it rains here on Earth, our droplets are made of water.
But the rain on Venus is sulfuric acid.
And lastly, when Earth rotates, the sun rises in the east and sets in the west.
But if we lived on Venus, the sun rises in the west and sets in the east.
There's actually only 2 planets in the whole solar system that rotate opposite to the way Earth rotates. Does anybody else know the other planet that spins the other way?
Mercury.
Oh, that's a really good guess. Oh, anybody else any of the big kids want to try a guess? What's the other spinning?
Mars?
Good try. Nope. You're right, Uranus. What's interesting is that Venus is so hot, but it's so similar to Earth in so many ways that a lot of exploration want to figure out if at one time Venus had oceans and an atmosphere like us. But what we realize happened on Venus is probably that they experienced a
runaway greenhouse effect.
So the runaway greenhouse effect is essentially where, and I don't want to go too far into Persis' slides, who will also describe what a greenhouse effect is like, but essentially it being so close to the sun, because of all the carbon dioxide in their atmosphere, instead of heat being able to escape and bounce off the planet, the heat gets clinged onto by all the carbon dioxide in the atmosphere, creating a very hot blanket around the planet where the heat can never escape from. The planet just gets progressively hotter and hotter and hotter.
Yeah, and on the inner core of our planet, it goes like out. But in the inner core on Venus, it keeps going back where it goes, and it keeps getting more hotter and hotter and hotter.
Right. That's true. And then the volcanoes erupt more and more often, which makes the air hotter, and so on and so forth. Thanks for adding that, buddy.
Okay.
So we are still continually interested in what's happening on Venus because it is so interesting that this is the planet that is closest to the composition of our planet. We actually have a new mission, or NASA has a new mission coming up called Da Vinci, and we actually have a little trailer to show because it's pretty interesting.
Launching in 2029, the Da Vinci mission, named after Leonardo da Vinci, is designed to address fundamental questions about the origin, evolution, and composition of Venus. During 2 gravity-assist flybys, Da Vinci will study the cloud tops in ultraviolet light, tracking cloud patterns as they change with time and analyzing signatures of mysterious chemicals that absorb ultraviolet light. Both flybys will also examine heat emanating from the Venus surface on the planet's night side. We will look for geological clues of this planet's mysterious past to paint a global picture of surface composition and the evolution of the planet's ancient highlands. 7 months after our second flyby, Da Vinci will release its atmospheric descent probe. The spacecraft will watch its probe enter Venus's atmosphere over the course of 2 days. The probe will take about an hour to fall through the atmosphere, taking measurements and snapping images down to the surface. These measurements include profiles of composition, winds, temperature, pressure, and acceleration. Key gases will be measured to help us understand how Venus formed and evolved. Some of these measurements may reveal chemical signatures of ancient water. With our suite of measurements, Da Vinci will provide new insights into Venus's atmosphere's complex composition, structure, and chemistry. As the probe nears the surface, its descent camera will capture breathtaking bird's-eye views of the mysterious terrain known as the Alpha Regio Tessera, possibly revealing evidence in the rocks that water once flowed across the Venusian surface. These up-close images of the surface will provide new insights into geologic processes and will help us to understand what it might be like to stand on the Venus surface. An oxygen-sensing student collaboration experiment will shed light on the role of this gas in the Venus atmosphere. The discoveries that emerge from this diverse dataset will tell us whether Venus was truly habitable, and the story we reveal at Venus will reach even beyond the solar system to analog exoplanets that will be observed with the James Webb Space Telescope. Venus is waiting for us all, and Da Vinci is ready to take us there and ignite a new Venus renaissance.
That's just our little intro to Venus. And we actually have Persis here from the Sustainability Task Force to talk more about what greenhouse gases are, because they're not only on our planet, but on Venus as well.
Hi everyone, my name is Persis. I am a rising senior at EBHS, the high school, and I will be talking a little bit about greenhouse gases, what they are, and their impact on our environment. So first, to understand what greenhouse gases are, I think it's important to first understand what the Earth's atmosphere is, what it's made up of, and basically what it does. So when I think about the Earth's atmosphere, I like to think about it as like an invisible blanket that covers the entirety of the Earth. And so this invisible blanket is made up of millions of molecules of gas. Gases like carbon dioxide, nitrogen, oxygen, methane, and water vapor. All these gases are continuously cycling within the atmosphere. Their levels are always rising, always falling. But out of these gases, the greenhouse gases, or the naturally occurring greenhouse gases, are what's listed above: carbon dioxide, methane, and water vapor. What makes these gases greenhouse gases and why they're so special is the fact that they're able to trap the heat that enters the Earth's atmosphere through rays of sunlight. And this is very important because the ability of these greenhouse gases to trap heat regulates Earth's temperature. Basically, these greenhouse gases will act as a gatekeeper for sunlight, balancing how much heat enters the Earth's atmosphere and how much heat leaves the Earth's atmosphere. And it does this through something called the greenhouse gas effect. And there are mainly two types of greenhouse gas effects, one of which is the naturally occurring greenhouse gas effect. And so how this works is when sun's rays are being emitted from the sun and entering the Earth's atmosphere, it enters as something called UV radiation. UV radiation will enter the Earth's atmosphere and it's absorbed by Earth's surfaces: parking lots, grasses, forests, water bodies like lakes, ponds, or oceans. And the Earth's surfaces will absorb this UV radiation to increase the heat of the Earth. And what's reflected off of these surfaces is a different type of radiation called infrared radiation. And this infrared radiation, as you can see on the diagram, is emitted back up into the atmosphere. And what these naturally occurring greenhouse gases will do is absorb the infrared radiation that was reflected and trap the heat into the Earth's atmosphere. It'll trap some of the heat to keep the Earth nice and warm, and it'll allow some of the rest of the infrared radiation to escape the atmosphere. And so the natural greenhouse gas effect is really important because it makes sure that our Earth is not freezing cold. Without the greenhouse gas effect, it would be like our Earth is like a block of ice. There would be no way for the Earth to regulate its temperature. If we think back to the Ice Age, the Earth was full of ice and below freezing temperatures, and life was just, nobody could live. Humans weren't alive, animals weren't alive, plants were alive, nothing was really living. With the natural greenhouse gas effect, the Earth is a nice, perfect temperature so that everybody can live and thrive. But the problem is that nowadays we're not really experiencing a natural greenhouse gas effect. We're experiencing more of what's called a human-enhanced greenhouse gas effect. And this is when there are too many greenhouse gases in the Earth's atmosphere, which means that too much heat is absorbed by these greenhouse gases and re-emitted back onto the Earth's surfaces. It's like when we're in bed and we have too many blankets on us, we get really uncomfortable, we get really sweaty. It's not a nice type of warmth, it's a very uncomfortable type of heat that we're experiencing with too many blankets on us. With the human-enhanced greenhouse gas effect, it's like the Earth has too many layers of blankets on it. And so the Earth is getting really sweaty, really uncomfortable. And so the question is, where are these extra greenhouse gases coming from? Well, they're coming from human activities. We burn things called non-renewable energy sources to power our cars and power our factories. Does anybody know some examples of non-renewable energy sources? Yeah, that's one. Does anybody else know any others? Potion? Pollution. That is an effect of us burning non-renewable energy sources. Yeah? Plastic. Yeah, we can be burning plastic. But yes, wood can be one. We burn gas, we burn coal, we burn wood. A lot of these things are found in very limited amounts on Earth's paper. We don't really burn paper. We use it more for our everyday activities, if you like to write or if you like to draw. But we burn these non-renewable energy sources, and what is a result is the emission of human-produced greenhouse gases, things like sulfur dioxide, nitrous oxide, and things called hydrofluorocarbons. These are not naturally present greenhouse gases, and a higher concentration of these in the atmosphere means that even more heat is trapped on Earth, creating a very, very hot Earth. And so this diagram shows you the difference between the amount of heat that is allowed to escape and the amount of heat that is allowed to stay if you compare the natural greenhouse gas effect and the human-enhanced greenhouse gas effect. You can see in the natural that the arrow where the heat is escaping is much thicker than the arrow that is being re-emitted back onto Earth's surface. So it's a nice balance of how much heat is being allowed to escape and how much heat is being allowed to stay. But if you look at the human-enhanced one, the arrow that is re-emitting back onto the Earth's surface is much, much thicker than the one that the heat is being allowed to escape. And you can also see that there are many, many more molecules of CO2 and methane. So this just goes to show that the human-enhanced greenhouse gas effect creates an imbalance in how much heat is allowed to escape and how much heat is allowed to stay. And so some of the consequences of this human-enhanced greenhouse gas effect, it's like the Earth has a fever, and what we call it, like scientifically, global warming. When we have a fever, our temperatures can get to 100 degrees, 101 degrees. If we're really sick, we can get to like 103 degrees. And when our internal body temperature is so high, our body can't perform our normal body activities. And the same concept can be applied to Earth. If the Earth is too hot, it can't perform its normal earthly activities. So things like regulating temperature. Since it's not able to regulate its temperature as well, and the heat is too high, the ice glaciers in the North and South Pole, or the Arctic and Antarctic, they melt, causing ocean levels to rise and creating risks for coastal communities, for beaches to flood. If you guys have been to the beaches in New Jersey, Florida, we've been to the West Coast, or beaches around the world, all these beaches are very threatened by flooding and rising ocean levels. Other things that can happen are we can see animal homes, plants, and even human homes. All of these can be disrupted by flooding that can result from higher ocean levels. And in addition to that, we can see a lot of crazy weather. You might have noticed this summer we're getting very, very hot. And this past winter, we had temperatures that were literally less than 10 degrees. I remember going out and I thought I wouldn't be able to survive the winter because it was just so cold, and now it's just so hot. So compared to past years, we're just experiencing a lot of crazy change in normal weather patterns. And this is really bad for our local biodiversity and just biodiversity all over the world. And so what we can do, we do have ways to try and help limit the harmful effects of human-enhanced, the human-enhanced greenhouse gas effect. So what I said before, we're now using a lot of non-renewable energy sources to power our cars or power our factories. But what we can try to do in the future is try to use more renewable energy sources. Does anybody know any examples of renewable energy sources? Yeah, we can use solar energy, that's one. Yeah, water, we can use dams and we can use the currents of the ocean. Yeah, we can use wind. There are big wind turbine farms. Any more? Well, those are a lot of the main ones. We can also use something called geothermal energy. It's when we harness the heat that's deep within the core. We harness that heat to run turbines and generators to generate more electricity. And there are other forms of non-renewable or renewable energy sources that we can use. But basically, by switching to more renewable energy sources, we're emitting less human-produced greenhouse gases and thus decreasing the concentration of greenhouse gases in the atmosphere. Other things we can do is be more smart with our transportation. Instead of driving, maybe we can take a walk, we can bike. If you want to get a little workout in, you can run to your destination. Other things we can do is be an environmental advocate. I think the most important thing that we can do is speak about these problems. A lot of the harmful effects that happen from the greenhouse gas effect, they're from human actions. And so a lot of the kids here today, you guys are the ones that are going to be making the big important decisions in 20 to 25 years. And you guys are going to be the ones that will be able to decide if we're going to be switching to renewable energy sources, if we're going to be making the smart choices for our environment. So if you take the time and you have the courage to speak and step up and talk about why these things are bad and how we can play our part into helping the environment and reducing some of the harmful effects of global warming and the greenhouse gas effect, I truly believe that we will be able to create a more balanced environment and create a more healthy biodiversity and healthy nature. And us humans can live in more harmony with the environment and nature. And so just to recap, greenhouse gases are good, but in high amounts, in the wrong amounts, they're very bad. Naturally occurring greenhouse gases, good. Without them, we would be living on an ice block. But human-produced greenhouse gases, bad. With them, we're basically living in an oven. And so a fun fact is that cows actually burp and fart methane, which is a greenhouse gas. But it's okay because they don't produce it. They don't burp or fart very high amounts of methane. So it's not a problem. The problem is the greenhouse gases that we produce. So we really need to focus on the greenhouse gases that we produce. The cows, we can keep them. It's okay. And yeah, that's it.
So I want to thank Persis for joining us and also linking us with the Sustainability Task Force. This is a nice reminder of, as an astronomy club, we focus a lot on the planets outside of ourselves, but it's also nice to kind of couple it with what's happening here on Earth as well. At this point, since this is like our seasonal kids meeting, we're actually going to have a little bit of a break from our typical structure. Usually what would happen after the presentation, we'd throw it over to Isaac to talk about what's in the sky, but we actually have some hands-on projects so we can learn a little bit more about Earth and Venus.
So if you see on the table, there are cups, toothpickers, and wind turbine things. And today, if you want, you can make your own wind turbine. And don't forget to fold it at the end.
So in the back, we have things like Kevin described. It's a set of 2 cups and 2 toothpicks, and there's instructions as well. We'll be back there to lead you as you go. But as Persis said, one of the ways we can create a reusable energy or renewable energy, thank you, is by using wind power, I think as you had said. So you can create your own wind turbine in the back. There's also a coloring sheet that talks about the things that we can do to keep Earth healthy. And on one side is Earth, and on the other side is our hotter twin, Venus. And we can do that. And we're gonna let everyone do a craft or do a hands-on project, and then we'll rejoin in a few minutes and actually do the regular astronomy club meeting portion where Isaac talks about what's in the sky tonight and telescopes things. So thank you guys.
Hi everyone, my name is Isaac Osores. I'm actually the president of the club. And could we just give Kevin and Christy and Persis another round of applause? They did such a wonderful job, and in fact, this is only our second kids club meeting that we've had. If you may not know, we're a very, very young club, but doing these kids meetings have given us an opportunity to collaborate with local organizations, which is excellent. The last one we did, we actually got to partner with the East Brunswick High School robotics team, and they brought their rover, which was pretty awesome. So it's just nice to be able to collaborate with other organizations in town. This was another opportunity to do so. And in fact, Christy did mention we do have another kids meeting in October, I believe it was? November, yes. So be on the lookout. And in fact, this is one of the reasons why we really do promote our social media, whether it's Instagram or Facebook. If you follow us, you'll be in the know when our next meeting is, when the next kids meeting is, any announcements that we're doing, any changes to the schedule, they'll be posted there. So please, by all means, follow us on Facebook or Instagram. We'll keep going. So typically in our club meetings, we have an area where we talk about the conditions overview. So up on the screen, I have screenshots of Astrospheric, which is a great app to use to see what the conditions will be a number of days in advance. And of course, as you get closer to the day, the more accurate it's going to be. I took these screenshots this afternoon, so that's as good as we're going to get without having to go outside. As you can see, it should be pretty clear, so we're hoping to at least see Mars. I think the moon doesn't come out until much, much later. In fact, I do like to share these screenshots as well when we talk about who's up there, what are we going to see. There's this planet visibility that's part of Stellarium, which is another app that I like to use. It shows the different things where there's the sun, the moon, and the different planets and what time they're going to be visible through this graph here at the bottom right. So based on this, we won't see the moon. That's not going to come out until after midnight. We may get to see Mars, so I'm hopeful that we'll be able to pull that. Has anyone seen Mars through a telescope yet? Don't brag. But it sounds like a lot of us haven't, so it'll be really cool if we can manage that. But with regards to the other planets and things, I don't think we'll be able to see those, even though it may be clear. With regards to the moon phase, I believe it's waning gibbous, and I think we'll have a new moon July 24th, the next full moon August 9th, but we'll continue on with the slides. As you may or may not know, the East Brunswick Astronomy Club is a part of UACNJ, which is the United Astronomy Clubs of New Jersey. And we do like to promote their meetings here at our club. And so they have free weekly programs at Jenny Jump State Forest every Saturday evening. And these are the next two that they have up. So I have the next two there, but really it's every Saturday, and I do encourage you to go. Certainly check the weather. They have a number of observatories that they do open to the public and let you take a look through. So depending on what's out, they'll give you a good chance to see through their telescopes and get a closer view. It is a bit further away, but in a way that's nice. You get away from the city lights and light pollution. I remember going there a couple years ago where I just got out the car and you could just see, sprinkles of stars that I wouldn't normally get to see if I just walked in my backyard in East Brunswick. So those are the next two. And then as part of our monthly meetings, we do have this section called open discussion where we really just talk about anything that's coming up, anything that you guys have interest in. So it's really more of a back and forth if you do have anything to share. But the one thing that I did bring up here is comet Neowise. So it was about 5 years ago now that it was actually visible in our area. And this is a picture that I took, and it's probably hard to see. Can you see that right there? So that's Comet Neowise. I took that with my phone. No fancy equipment. In fact, it was actually at the East Brunswick Community Arts Center. So I may have been there past sundown. Don't tell anyone. But I had to take the opportunity to take this picture of Comet Neowise based on stellarium and the conditions. It was just clear, and it was going to be, I knew where it was going to be. I just had to find a good place that had minimal trees and light pollution. Granted, you could see that street light there, which kind of ruins it, but I'm still pretty proud of this picture. It was my first comet picture. I did put a little blurb, which is hard to read from where I was sitting, but this comet was discovered by NASA's Neowise mission. It made its closest approach to the sun in July 5 years ago and became very visible in the evening sky. This comet is not expected to return to the inner solar system for another 6,800 years. So, good luck. But thankfully, I mean, there have been other comets that have made their way close to us. The Green Devil Comet.
His nickname was the Green Devil Comet. I don't remember its designation.
Yeah. And for that one, I was fortunate enough to have my smart telescope, which did a nice job of actually finding the comet. And I just had to find, again, a clear area where I could actually take a look at it. So that one was a little easier to take than propping my phone on the grass and setting up to do like a long exposure. But, you know, we'll certainly let you know when the next one is. It'll come up in our open discussion. And hopefully we can have some of you submit your pictures, and we're happy to share them on social media or even having it here in open discussion. So keep that in mind. The other thing I had to talk about was the Perseids meteor shower. It actually starts today and goes through the end of August, but its peak won't be until August 12th or so. The best time to view the shower is after midnight in the constellation Perseus. And there's a picture that I found online of one of the meteors. So another open discussion item that I have is our August meeting. It falls on August 21st. I'm not sure if is that accurate? Is it the third Thursday? So if so, that is our next meeting, August 21st. But it's a special meeting where we're trying something new that we haven't done before. We're calling it the quick fire presentations. Typically, if you haven't been to our club, we'll have a guest presenter come and talk about something that they're very familiar with. One of the more recent ones was in regards to pulsars, which is a very, very great presentation. I highly recommend it. It is on YouTube. However, for this one, what we thought we would do is really flip the table. Is really have someone like you who may be interested in presenting something astronomy related and have it be done for 5 minutes, 10 if you really want to, but really short presentation, something astronomy related, and then open it up to the public and have you and a couple of you actually present for the club. So if you are interested, let me know. I'm happy to give you some additional details, what's involved. But if you are interested or have questions, our email is on the screen, info@ebastro.org. And if you are interested, you can scan the QR code on the slide or click on the link when we do share the slides. It'll bring you to a form where you can submit your general information and what your topic will be about. So if you are interested, let us know. We thought it'd be fun to have, folks like you guys just come present if you're interested.